Hey guys, welcome back to week 2. This is going to be more of our upper level, high school level math. This week is actually a request sent by one of my students. It was a specific homework question that she had, and it is going to be very geometry specific, okay? So we're going to be talking about area of regular polygons. The specific question was, if you have an octagon, specify a regular octagon with a side length of 6 centimeters, what is the area? And this is the exact question. It was written out in sentence form. It did not have a picture. This is all we were given, right? So let's take a quick second and make that drawing ourselves. So we're going to go ahead and sketch out an octagon, of course, which is an 8-sided figure. And it doesn't have to be perfect. We're just trying to get the idea going here. We know that the side length we were given was 6 centimeters. And from the center of our polygon to a vertice, this straight line is going to be called our radius. These are our side lengths. And then, of course, this dotted line I'm drawing is our apothem. We know that an apothem goes from the center down to the middle and forms a right angle with our side. The apothem is helpful because our formula for area of a regular polygon is 1/2 apothem times perimeter. Now, the perimeter of an octagon, if all of these sides are 6 centimeters all the way around, 6 times 8, our perimeter is going to be 48. So now looking at our formula, the thing that we're missing is our apothem. The first thing we want to go back and look at is how that apothem forms a right angle with our side length, or our side down at the bottom. And that right angle also forms a right triangle, right? I'm going to highlight that here in pink. Looking at this right triangle, at this point in geometry, we know quite a bit about right triangles and what we can do with them. I am labeling that bottom leg of the right triangle as 3 centimeters since it is half of our side length. We're not really focusing on the radius or the hypotenuse in this case. We're looking for the apothem. We also know that as we go around the octagon, this same pink triangle is going to occur 16 times, right? It'll happen twice per side length. There are 8 side lengths, so it's going to occur 16 times. All the way around is going to be 360 degrees. So 360 divided by 16. If we transition over to a calculator app, we can just type in 360 divided by 16 and get 22.5. So we'll fill that in here, 22.5 degrees. Where does that angle apply? Well, it applies up here at the top of that right triangle. We know that the top of the right triangle is 22.5 degrees. And we are now going to dive into our trigonometry that we've learned. The phrase SOHCAHTOA is helpful here, so we can identify which trig function we need to solve for the apothem or our missing side. I have an angle, a side, and I'm looking for another side. That's kind of the key that's giving me that I should use trigonometric functions. And since I have the angle up at the top, and from there I have its opposite, and I need its adjacent, looking for adjacent and opposite, opposite adjacent, I'm going to use tangent. So I'm going to go ahead and set up what I'm solving for, which is the tangent of 22.5 degrees, which is equal to 3 over A, or my apothem. From here, I'm going to go ahead and solve this. I can multiply both sides by A. Let's move this over so we have some room. Doing so will cancel out on the right side, but leave me A times tangent 22.5 on the left, which is equal to 3. If I divide by tangent 22.5 on both sides, cancels out on the left and leaves me A is equal to 3 over tangent of 22.5. This is going to be the piece that we're going to go and plug into our calculator. This time I'm going to go over to Safari and use the Desmos graphing calculator, type in 3 over the tangent of 22.5, which gives us an answer. But since we typed in 22.5 degrees, we need to make sure our settings are in degrees and not radians. So that gives us a value here of, I believe I'm going to round it here to 3 places, so 7.243, which is our A, or our apothem. Now that we have our A value, now remember our formula for area was area equals 1/2 apothem times perimeter. We have our A, we have our perimeter. Let's go ahead and plug all that in. We need 1/2 of 7.243 times 48. Again, all of this can go back into the calculator. I'm going to do it both ways. I'm going to type it in with the rounded value that we had, and then as well by actually doing the entire math. So first, we've got the rounded value plugged in times 48, which gives us 173.832. Now I can also with Desmos go back up and just edit the original one, multiply this entire thing by 1/2, and then again by 48, which gives me 173.823. So it's a little different, but if we're rounding to the 10th place, which is question asked for, it's still going to come out the same. Going to go ahead and box up our answer. So if we were looking for the area of a regular octagon that had a side length of 6 centimeters, that area is 173.8 centimeters squared. As always, here it is, a screenshot for your notes. Let me know if you have questions.